So, the most asked question by children would be, why is the sky blue? And it's a very good question, and it's a question in which adults give the wrong answer to the children. It's really sad too. Now, I admit that I had to think about that a little bit too. There's three factors that really made me consider why the sky was blue. One is because I thought that the glass sky is yellow in nature. If we look at pieces of Libyan desert glass, we see them as yellow, and I thought there was some kind of color inversion going on there. Maybe it has to do with, originally I was thinking it must be like phosphorus or something in the atmosphere that it switched to color. I'm not a scientist, so I'm just kind of think, why would that change? Why would there be, there might be some kind of inversion, and or maybe it's some kind of polarizing effect, because we know that the sky is polarized and the glass does polarize the sky. However, there's some other options too. Obviously, the main reason people tell you, the main explanation is Rayleigh scattering, which they say the blue light is a shorter wavelength than the red light, and the blue gets scattered more than the red. But then the question arises, well, why isn't the sky violet then? Because violet has the shortest wavelength. And they will tell you that because our eyes don't pick up violet as well as blue. And that's, like this guy asks over here.
Because it's so short. If that's the case, why isn't the sky violet?
Okay, here's the thing. The sky...
This guy's a shill. It's kind of pathetic too. Him and Vsauce. It's like they own the internet scientific community, and it's all bullshit. So he will go into, our eyes don't pick up violet as well as blue. Then I did some more research. And then I got to thinking about the electricity that's involved within the concave Earth, within this universe. It's an electric universe, okay? And the sun is the electrode, and the glass sky. See, this is the biggest problem with conventional science, is they will omit any reference to a glass sky, even though there's overwhelming evidence. And so glass, as you know, is an insulator. It's a dielectric insulator. And so I was doing some research on plasma cleaning. Let's go over here. And they have this plasma cleaner. And what it does is it creates the glass is the dielectric barrier discharge. It creates a plasmic discharge. And so there's oxygen within this tube, within this glass tube, and it emits a blue light. Go over here. Show you over here. Plasma cleaning involves removal of impurities and contaminants of an energetic through the use of an energetic plasma or dielectric barrier discharge. Okay, so this glass is the dielectric, it's the barrier, and it's discharging the plasma, which happens to be filled with oxygen. Argon, oxygen, so these are all the same elements that we have in our atmosphere. We have oxygen, nitrogen, argon. It says in plasma, gas atoms are excited to higher energy states and also ionized. As the atoms and molecules relax to the normal, lower energy states, they release a photon of light. This results in the characteristic glow or light associated with plasma. Different gases give different colors. For example, oxygen plasma emits a light blue color. So it's right there. The explanation of why the sky is blue is because of the plasma, the oxygen in the atmosphere, and the fact that it's being emitted by the dielectric barrier discharge glass sky. So I made a little pretty graphic here where I show how excuse me, how the sun, okay, let's go back here for a second here. They have this little diagram here, okay? You have a high voltage electrode on one side, and then you have a ground electrode on the other side. So sandwiched between that is the dielectric barrier and the discharge. So in my graphic, the dielectric barrier would be the glass sky, and the discharge would be the oxygen emitting the plasma, as you see here. So we have the sun, high voltage electrode, The glass sky is the dielectric barrier. The oxygen plasma is the discharge, and then we have a ground electrode. So we have a beautiful capacitor going on here with the glass. The glass is creating the blue plasma. Now when it's red at the sunset or sunrise, I believe that the actual glass sky is is refracting the colors. Red, as I told you before in a previous video, red is the least refracted color, and so all the other colors get refracted away. So that's why we pick up the red. But the blue, I do believe it's because of the glass sky acting as a dielectric barrier that discharges the oxygen. You know, we have the ozone, right? The ozone layer, it's below the stratosphere. So that's why when we get up higher, the sky does not stay blue anymore. We're out of the oxygen zone. We're out of the ozone. Okay, it's very simple, guys. Once you understand, we're living in the concave Earth, the concave stationary Earth. There's a glass sky that acts as a dielectric barrier, an insulator, which creates this plasma. It's very simple. That's why the sky is blue. Okay. See, what I did is, this is a piece of Libyan desert glass, and I was thinking, well, okay, if I hide that layer, this is the same blue color from the plasma cleaner I have here. And so if I overlaid that Libyan desert glass color with an additive light, so let's just go overlay, it really does not affect the blue that much. So that's why I negated the yellow glass, acting as some kind of color inversion to create the blue sky. So plus when we look along the horizon, we see the blue mist. I mean, if we look at like in mountains like 5 miles away, we'll see they are being gelled through this blue, and that's the plasma. That's the plasma in the atmosphere, the oxygen. And that's due to the fact that we are underneath a glass sky that acts as a dielectric barrier, which discharges the plasma. So this is the real reason why the sky is blue. So hopefully you can pass this video around to people and explain to them. You know, people who think that it's Rayleigh scattering. Oh, gotta go. All right, talk to you later, guys.